Hello all. Hey, I want to call this next video the pre-chapter 8, the pre-week 6 video, because I'm getting still a lot of questions and a lot of people aren't understanding why we're doing what we're doing. We just, all the opinion is we're just drawing lines kind of anywhere, just kind of going through the commands. But how are we gonna paste all this together? Okay, so I'm still going to do the video series that walks you through the final project, but this is just kind of a quick and dirty um, exhibition of how the Civil 3D elements operate. Remember, I mentioned it very early in the class that they are reactive, they are data driven, and they're excuse me, excuse me, and that they're ripple through when they have a ripple through effect. Okay, so what I'm going to demonstrate right now is two of those three, which are reactive and the ripple through effect. All right, so let me first demonstrate the reactive. So let me go down here, and first let's take a look at a 2D object, which is this parcel here. So we created this parcel, and basically the bearings are basically going true north or west and east, and that's not very exciting. They're just kind of really boring bearings. But if we were to pull it out, let's say the surveyor came back in and he constructed some new geometry, and he put a point, say he told us to run a traverse this way, and he says stick this point right here, right on that vertice. Okay, let's go over here and we'll move it, and notice that these bearings changed. Okay, so the text is reactive, and if there was anything else hinged onto these parcel lines, like let's say just as an example, let's say the grading groups had been hinged on this parcel line, those grading groups would change in order to affect the parcel change. Okay, but that's a little advanced for you right now. But you've created the parcel line so you can understand how that works. Okay, let's take another example of how something is reactive. Let's zoom down in here. Now here we have two surfaces. We have the existing surface that is kind of like a breathing, living organism in itself. It's a live object because it's taken stuff in to create it, and then it exhales out information, and we just need to know how to pluck that information out. Okay, so again, I mentioned that those are two surfaces that are interacting with each other, and we can see the two surfaces, and we can see that there's an error here. Okay, it drops straight down, and we're going to fix that a little bit. But anyway, there's two surfaces, the existing and the proposed road. Okay, so let's show you how the reactive works on the surfaces. We'll go to annotate, add labels. We'll say surface, spot elevations, and we'll pick the existing surface first. Okay, all you have to do is hit a contour, it knows. Okay, and I go ahead and place a spot elevation there. And if I highlight the spot elevation and go to properties, I notice that it is referencing, the spot elevation is referencing the existing ground right there. Okay, so I don't like the style. Well, let me tell you what the style is. The style is reading feet and meters. Okay, so what I want is a standard style, and I'll go ahead and I'll change it to just standard. Say okay. Now we have something that looks fairly normal, and I'm going to show you the drag state. Okay, if I drag it out of its position, it's still pointing to the same spot, but notice how there's now a little arrow and a little leader included with it. That's part of its reactiveness, but that's within the component itself. That's within the spot elevation. All right. Now, notice when I move the spot elevation around, notice the elevation change. 328.26, 329.34. So it's actually drawing information from the DTM. Whereas back in the old days when we were working in LDD, it wouldn't. There was only one command that you could issue that could extract the information, but if there was anything, if there was any deviation in the way the surface was built or how you modified or anything, that function wouldn't work. This is totally 100% improvement than what it used to be. Okay, let's go back to annotation, and we're going to add a label. we're going to another spot elevation. And this time we're going to take the surface of the corridor. We're going to touch the corridor contour, and we're going to pluck that in there. And notice, same thing, we're reading English and metric. Now I want to show you, I want to change the style of this as well, but I'm going to show you a different way. Type the command MA for match properties, select the thing you want it to look like, and then select the object you want to change, and there you go. It changes it to what you want to look like. Okay, so let me move that. And again, it is reading the surface of the corridor. Let's highlight that text. Let's go to the properties manager here. And look at the surface it's referencing is the access road. So that's exactly what you want. Okay. Now, I don't want to modify the existing surface, so I'm going to go ahead and modify the corridor. Now, I can't see the PIs here, but if I had the PIs shown, I can pull one of the PIs out and stretch this corridor everywhere. If I did that, that would cause a ripple through effect by changing this profile here. Okay, and I'm going to show you the profile view by changing the vertical alignment as opposed to the horizontal on the alignment. Let me talk about a couple of things first, real quick. And a lot of people don't understand how this works. Okay, when we're dealing with a corridor or a road, there's a trinitarian kind of component that you need to understand. You need to have, first of all, to create a corridor, an alignment, okay? And an alignment has stations on it, okay? And these stations are in 100-foot increments, 800, 900, 1,000. And on occasion, they give you half increments. So that's half stations, and those are every 50 feet. So it'd be 800, and it'd have a tick, but not necessarily the number. 900, tick at 950, and then 1,000, and then a tick at 1,050, okay? Now the stationing down on the profile match the alignment exactly because they have a symbiotic relationship. The corridor, the profile alignment is dictated by the horizontal alignment, okay? And final component for the corridor is the section, not a cross section. This is a section comprised of sub-assemblies. So this is an assembly, call it a template as well, and it's comprised of sub-assemblies. Now there was only a couple of you in exercise 2 that got to the point where you could create the sub-assembly, and that was a shame because I think it could have answered a lot of questions. Okay, remember we had that error here on the end, and I'm going to fix it, okay? Let's pan the 3D view over here. So all I need to do now, here's another example of reactive, okay? And ripple through. I'm going to go ahead and move this, and I'm going to move it a little bit more, okay? Now, nothing changed, but that's okay. That's because I have to rebuild a corridor, and hopefully the computer won't crash because it crashes a lot at this point. Okay, it fixed it. See, notice it's all hunky-dory now. So let's go back to those 2 tags, elevation tags that I had, and make note of what the elevation tag is right now. It's 325.25, okay? Now I'm going to go to the profile, and I'm going to elevate that sag. Let's find out where that sag is at. That sag is at 350, about 350, station 350. 356 exactly. Now I'm going to zoom over here. That's 400, so 350 is right in here, okay? So what I'm going to do is I'm going to lift this up, okay? And you can see that the profile changes automatically. Now back in the old days, no, it didn't do it. We had to redefine it. Yeah, it was a actual command. We had to redefine the profile. Okay, but still it hasn't done anything to the corridor, and that's because I have to rebuild it. Now I could set the rebuilding to automatic, but you don't want to do that. If it's a simple corridor, yeah, you can go ahead and do that. But if it's a complicated corridor, you run the risk of the computer crashing. So I tend to want to control that, okay? So now I highlight the corridor. Here we go. And I'm going to right click. Oops, I must have selected non-corridor objects. Okay, right click, rebuild a corridor. Now watch the pavement come up here. Boom, it's just jumped up, okay? because I've lifted up the pavement design. And remember that elevation was 325.25? Now it's 333.77. So I'm going to go ahead and drop this back down. And I'm going to go ahead and rebuild the corridor. Rebuild corridor. Bam. Okay, now it's back down to 327.87. Okay, I didn't put exactly where it was before. But, so, as you can see, as I pump information in, it's breathing back information back. And that's what the engineers want. They want this to be built so that if you change it, it changes the your information on the fly. Okay, it's not just a program to make the nice pretty 3D geometry. It actually, you can retrieve information back from it. Okay, so this is the end goal. This is where we're actually heading to. And I'll go to the layout, and I went ahead and created a little plan and profile sheet. And this is ultimately what you want. You want the model to, you want to draft on the 3D model. And that 3D model, all the text and items that you're putting in there are all based on reactive text, so that if you have to come back and change the design, all that text changes, saving you just tons of time. Okay, so that's the end of this little video, and I hopefully it answered some questions and filled in some gaps. But what you're doing is you're actually learning how to design in 3D, set up your annotation so that it's reactive and changes as the design changes. Okay, I will now venture off into the exercise, the week 6 exercise 8 series.